Okay, so today, let's start with this guy. We need a bit of practice for you. I don't like this. I don't know if I can ever go back to a traditional classroom now. Oh, you're on the one that's whack, wiggity whack. Right. Because the two workers are down here.
What's that? What's that all about?
Wow.
I'm sorry. I'm
What kind of cheese would you like?
really upset about it.
Huh?
I'm just upset about it.
Well, roll her out of the way and take that side. This side doesn't move,
I
see?
know. It does.
Or you can go sit next to Elon. Well, there's a solo desk back there where we won't have to listen to you, because you'll be in the back corner.
It's okay. I'm okay.
You're gonna be able to work through this?
Yeah, I can.
Good, good. Good job.
I didn't start the question yet.
Once you get an answer, check with your neighbor, if you have a neighbor. Question in the back, sir. Hold on 1 second. Yeah, that'd be a good idea. Then Eli won't feel so alone, and you won't feel so alone.
Wow.
Jack, catch. Come on.
That's it.
See the little square down at the bottom?
Yeah.
Press that. You want a whole screen to work with, or can you work on that screen?
I can work on here.
Okay. Choose color.
Don't care.
Would just be.
That's how I did it with
Is this good? It's good now?
Knock yourself out.
Alright.
Please, ladies and gentlemen, give Jack his your full and undivided attention. I think he deserves it.
Hi, Jack.
I didn't say hi. I didn't tell you to say hi to him. I just said give him your undivided attention. He doesn't want you.
What's up?
I can't read that.
Oh, my B.
Please do that.
Oh. Yeah, I don't know, I just read it that way. I can't write it.
Corrections, please, sir.
Oh.
I write it again.
He's got the technology down and everything.
This is the part I'm bad at. I don't like fractions.
What is
No.
My bad. Just the exponent.
Make the decimal.
Oh.
Yeah, turn 0.5 into a fraction. There you go.
There we
All
go.
right. Before you sit down, could you explain that to us, please, while you're up there?
Yeah, you just take the 4, multiply by the 5, so that's 20. Subtract 1 from the exponent, so it's 20x to the third.
That's easy one, good.
You do the negative 6 times negative 3, which is positive 18, minus 1 from the exponent, negative 7.
Hold on a second. Confession time. Who had -5? What? Okay, thank you. I knew there was at least one of you. Back to you, Jack.
And then this is an exponent of 1 over 2, so you multiply the 1 over 2 by 12, that's 6, and then subtract 1, so it's negative 1/2.
Beautiful. Thank you, let's give it up to Jack. In the future, that's not going to be an acceptable answer. We're going to have to clean that up. What do you think is going to need to be cleaned up? Negative exponent. So if we do that in a lovely shade of red, we would get 20x cubed plus 18 over x to the 7th plus 6 over the square root of x. Or you could leave it as x to the 1/2. Okay, good. Any problems there?
With radicals in the denominator, okay, for you, right?
Why would I not be?
Because like last year, we had to like rationalize the denominator.
How long am I waiting?
What?
Keep 7 or 8.
Yeah. You had a question, Tim?
Having
Is not a good way to start a question. Start over.
having radicals in the denominator is okay, correct?
Certainly. Yeah, we do not have to rationalize denominators. That's Bush League stuff. Question here in front.
Yeah, for the coefficients of the x to the negative 7th and x to the negative 1/2, why is it not like 20x to the 3rd over 18x to the 7th plus 6x to the 1/2?
Wait, I'm sorry. Start over again.
So like, why is it not, why do the coefficients not also go in the denominator with like 20x to the 3rd?
I see what you're saying. Because the coefficients aren't being raised to the negative exponent. It's only the stuff. So you want to think of it this way. Okay, so it's only the x being raised to the negative 7th. It's only the x being raised to the negative 1/2. Okie dokie. What are we going to do today?
Nothing.
Right, we're just going to sit in a circle and talk about our feelings.
Yeah.
No, we cannot. I don't really care about your feelings. You should know that by now. We want to look at the, I went past it when we did this. That's what we're doing today. Product and quotient. So, big mistake that people make early on is taking the derivative of a product as the product of the derivatives. That doesn't work, nor does it work with quotients. There are rules that need to be followed, much like life. Okay, so we're going to talk about that today. So we're going to do product rule, we're going to do a quotient rule, we're going to do some trig, because everybody loves trig. Another double thumbs up from Jen. And of course, your goal for today, try to be nice to at least one freshman. At least one, that's all I'm asking, okay? Is it that difficult? The business about higher order derivatives, easy peasy, we've done that already. Take the derivative of a function, you get f prime of x, for instance. Well, what's stopping us from taking a derivative again? Nothing. So we can do it again, and if we took f of x to get f prime of x, if we take the derivative of f prime of x, what do you figure we'd get?
F prime prime.
F prime prime, also known as f double prime. And if you take the derivative of f double prime, you get f triple prime, etc., etc., etc. So, let's try that guy. Take the derivative of h of x. Huh?
Never mind, I was just
Good question.
about something.
Okay, you're just thinking when you went to your happy place? Or Okay, stop you. Let me stop you for a second to make sure none of you go down this this bad path. The answer to that question is not 3 minus 4x times the quantity 4. Right? Because you can't do that. The derivative of a function that's a product is not the derivative of the first term times the derivative of the second. We have to find another way to do it. You have two options here. One of them you don't know yet, which is the product rule. But there is another way that you can do this problem. How? What is it? Multiply it out. You could multiply that puppy out, which I have here somewhere. Yes, there it is. Not too bad. However, what if the function gets uglier? What if, for instance, I raise that 3x minus 2x squared to the 4th power? I'm not multiplying that thing out, nor are you. We're going to come up with some rules here. And we'll come back to this example after we learn about the product rule. Here's the product rule, in fancy edu-speak. Yeah. Okay, so let's talk about a couple words that are in this spiel up there. Differentiable functions. That means that in order for this to work, the individual functions have to be differentiable. Meaning, you could take the derivative of them. There are certain functions that are non-differentiable. What does that mean in English? Okay, good. It's pretty much up there. What's f of x? Just f of x. What's g prime of x? It's not a trick question. G prime of x. It's just g prime of x. It's the derivative of g. So, first times the derivative of the second plus the second times the derivative of the first. You could do that in either order, but I like to do it in that order. It doesn't matter, you know, because it's commutative. 1 plus 2, same thing as 2 plus 1. Let's go back.
Go back.
Okay, here we go.
h prime of x is the first 3x minus 2x squared times the derivative of the second, which is? Plus the derivative of the first, 3 minus 4x, times the second, 5 plus 4x.
It would be nice if we could stop there, but guess what? We can't.
Molly, quickly, what's this?
3 minus 4x.
Sorry.
Oh.
Molly, what's this?
12x minus x squared.
Quickly, Molly, what's this?
Me? 15 minus 20x plus 16x minus 12x. Minus.
12x minus.
Would you tap out on that one? I can't go on, I can't go on!
16x.
When you write your answers, try to write them in decreasing form, meaning put the biggest degree to the left, the smallest degree to the right. Whoopsh, whoopsh. -8%.
Wait,
what? Okay, raise it.
cancel out.
-8 plus 12x.
What?
Negative 20x plus 12x is -8x plus 12x is positive 4x. Or if you prefer, 12x plus 12x is 24x minus 20x is 4x. Or 12x minus 20x is -4x plus 12x. Yeah. Plus 15.
Wow.
You in the back.
So like, how would like, which way do you like? Do we get to choose any way we want to do this kind of problem?
I'm gonna give you two answers. One, the proper educational answer, and that would be yes. Second would be the sarcastic answer. I would prefer if you do it the right way. I prefer. What do you think I said?
He said, I prefer.
I heard prefer.
I prefer? I did not say prefer. Why would I change an F into a V? I know the English language pretty good. I stink.
Hey, what's H double prime?
What?
Negative 48x plus 4.
Negative 48x.
What about H triple prime?
Negative 48.
How about H quadruple prime?
0.
How about H quintuple prime?
0.
Are you recognizing a pattern here? What happens to the degree every time you take the derivative? Goes down 1, right? Okay? Did anybody finish the initial problem by, what we did? Is that the right answer?
Yeah.
Okay, good.
Isn't that similar to synthetic division?
What? What?
Because that's what you do with synthetic division. Every time it goes down.
I'm not saying anything.
Not go over this.
Can you ever go up and explain it?
No, I mean, that would be some thought that crossed my mind.
No, that's not necessarily true in synthetic division. If you divide a function by a linear term, then yes, it will decrease by 1, but you could divide it by a quadratic or a quintic or a cubic or a octic.
That's not, oh wait, that's not the answer. That's it. Oh, I'm so tired. Quotient rule. Holy guacamole.
This one, people screw up all the time. I mean, you want me to lie to you? Okay, this is the easiest thing we're ever gonna do. This is like rainbows and unicorns.
That's hard.
Okay, so there it is. F of x divided by g of x. When I want to take the derivative of that, I get that mess. Now, I'll show you how I do it to remember it. Maybe that'll help you. Maybe you've got something else that you have planned. Whatever it takes to remember this, because there's a lot of places to screw up here. For instance, what's on the bottom square? Which one do you do first? Is it a minus or a plus? Those are all places where I see numerous mistakes. There's some stuff up in the spiel up ahead, like g of x can't be equal to 0. Because we're dealing with real numbers here. Denominators can never be 0. But other than that, we're good to go. Shall we try one? Are we good to go?
We'll find out.
No, I mean, are you good to go in that you have the rule written down?
No.
Oh, watch out for that.
Killed myself.
Oh, it's on now, buddy boy. About 2 more seconds, your backpack's gonna be on the chair and you're gonna be sitting on the floor or jammed under the seat.
I would have died if my iPad was community kicked in front of
It's not, it's on your desk, I looked.
Yeah, I know, but if it was. That would've-
I just lied. Yeah, okay, here we go.
Hold on, I'm centering my chi before I get started here. Y prime. Okay, so when I do quotient rules, I start with a big gazinta bar. And I start with the denominator. So you take the denominator, leave it on the bottom, and square it. Take that denominator, move it up to the top. Don't get sloppy with parentheses. Because you brought that denominator up to the top, I don't want to take the derivative of the denominator, I want to do the derivative of the numerator. Minus. You just got to remember it's minus. Muy importante. Put a big honk in parentheses or a bracket or a brace, some type of grouping item, and switch this. So this was the denominator times the derivative of the numerator. So we want the numerator times the derivative of the denominator. Sometimes you have to extend your Gesundheit bar. That's the hard part. The rest is easy peasy. To make your life a lot easier, we're going to follow a simple rule. That is, always simplify numerators, don't touch denominators. Okay, so I don't want to multiply out the denominator, leave it alone. 5x squared plus 5 minus big honkin' bracket. 10x squared minus 4x. All over x squared plus 1 quantity squared, which gives me negative 5x squared plus 4x plus 5 all over x squared plus 1 quantity squared. Okay. Early on, I'm more concerned that you can do the quotient rule. Difficulty is going to happen in the future when we have to simplify that further. So we'll talk about factoring things out. We'll talk about canceling. We're talking about all kinds of some of those weird tricks that they throw at us. But for now, I'm happy if you can get to that. The next question would be, does that numerator factor? Or is there something that can be factored out of the numerator? Okay, I don't think that one factors. I could always fire up my calculator and do quadratic formula and see if it works, but I'll leave it like that for now. Do you also see then that we could do y double prime? And that will become a little bit more interesting. We'd have a fourth term on the bottom and a polarity ensues. Okay. We good? Any problems? Awesome. Nope. We're done. Okay. So we'll save that other stuff, which is trig and higher order derivatives for later on. Thought you'd enjoy that. Okay. Tonight's homework is a combination of two things. It's the rest of 2-2 and the start of 2-3. Gesundheit. Please do those on separate pieces of paper. Let me say that again. Please do those on separate pieces of paper so I can collect all of 2-2 tomorrow. And you have 2-3 to keep with you. Day 20, no, 27, isn't it? Am I off?
Day 26 on the calendar, yeah.
It's day 26. I'm sorry, I'll fix it. I have failed you.
There's one